everybody, this is Pete from PA Labs, and this video is going to be on files. And we all use files. We know what they are. Um, Open up a file, write text to it. Maybe you even have INI files, and there's all kinds of stuff that we do for files. We use them in temporary manner and write to the temporary folders, and we deal with image files and binary files all the time. But files is worth a good serious look at because they've got some capabilities that are really, really nice. Other than just, okay, so I've put some stuff here. I brought over a procedure from my static that I got from the PureBasic forums that actually will recycle a file for Windows folks. And it just moves it to the recycle folder instead of deleting it, because in PureBasic, when you delete a file, that sucker is gone. So sometimes you don't really want to do that, especially if it's like a user file where they're keeping track of their stuff and you're saving it to a file. You don't really want to kill it. You want to move it into the recycle so they can go back to it and go, oh, I didn't want to do that, that kind of thing. So I want to make sure everybody knows how to lay their hands on the local temporary directory. So that's in here. You can actually have PureBasic bring back a temporary file name, but that's kind of not really the scope here. This is for the developer when we want to create files. Okay, it's a standard thing. First, you make sure it's not there to begin with, because you can leave this step off because I believe create or open automatic. This create, I think it's create file will override. If it's already exists, it'll be overwritten. And then open, let me see. Okay, so open doesn't automatically overwrite. Overwrite, you need to use the create. Also, you can use a read file. All of those are the opening commands. So really, you got three. You can create it with open. You have read file. Okay. And of course, you have to have the number. So, and then what was the other one? Create file, read file, and what is this? Open file. Okay, so all of these have nuance differences, but it's up to you which one you want to use. And as with everything you see in PureBasic, when you go to create something, be it a font, be it an image, anything, you have PB any, or you supply it an ID of your own, okay? Which is really all the enumeration system is. We're supplying our own number. Oh, pop-ups. God, don't we hate those? I use 6 a lot, zeros used a lot, 10. I pick my number, it doesn't matter, kind of randomly out of my head, whatever I'm thinking about. 42 comes to mind a lot too. And so you create a file, you issue it an identity ID, and then here's your, you got to give a path and a file name, and then you can write a string. And there's two different ways to write strings. And that's kind of what I want to get into today is some of this. You can write string, no N. The N says write the string. And oh, by the way, this is a new line. So give me a carriage return on the end of it. The next thing I write will be on the next line of the file versus the write string. Here, we can do this and say, okay. And this says write a string and then wait right there, because my next command is going to be Write string hello. We could actually say, why don't we say hello? And and then of course we would want to put a space after that or a space leading on the hello Bob. Okay. So those two words would be put together, and then at the end we can put him with the carriage return. So in those three sentences, we've written two lines to the file itself. So there's an awful lot of right variable type. Okay. But let's go ahead and finish this code. So when we create a file, normally you want to kill it or call up here to recycle and recycle it. So that kind of finishes that vein of thought. And that one thing right there we do many, many times. But really what I'm wanting to draw your attention to today is all these other reads. You can read ASCII character, byte, character, data, double, float. Remember, many times, and in many of my applications, I actually do the whole convert to JSON, right? So when I want to back up an object, I'll convert to JSON. We'll convert to JSON and then save the JSON. And there's nothing wrong with that, except, I mean, it's extremely fast. It takes an entire object tree. I mean, you can have 87 million different objects inside your tree. As long as it all can collapse up into one parent object, then you can convert it to JSON and save it in a heartbeat to a database. Okay. I don't care how long it is. 100,000 lines of pretty print JSON is no big deal. So that's got its merit. However, if you have editors, editor data, if you have images, if you have those are the biggies, but you could actually have binary files, you could have quads, you could have dates, you could have all manner of different data types, right? And JSON doesn't really deal with all the data types like we would want. He pretty much kind of renders everybody to a string and says, there you go. And then when you reconstitute it back, he reconstitutes it from a string. But some of these he has a real problem with. Well, that's where these other data types come in. Like when I get in the war game to the point that we are going to be saving your game in progress. So what I'm going to do is not save it as a JSON file, not deal with, sprite sheets and all of that junk. We're going to do an export, and an export basically is a function to me. I build them. They're manually created. An export function that will then export the entire tree structure. Every one of my objects has an export function built into it. So if it is a parent-child array or a list of some kind, no big deal. The first piece of the export will come out here and say, we'll write an integer. Okay, so write integer. Whoops, wait a minute. We can write integer TEGER. So we write the integer. Sorry, and this would be the list size of whatever the list is that I'm gonna uh, output, and then we'll do a 4x, or actually, I'm trying to not type it because I screw it up every time just about. Okay, so we're going to 4x to that integer I just wrote, and then we're going to save each and every field in the records will have their own right string, you know, uh, NGN, you know, that kind of thing. And and so it physically writes out the data one item per line. And then when you get to things like clobs, you can actually write the clob. If you get to a blob, a binary, no big deal. You just write the binary out, just like we read it in. And your first piece of a binary is his size, right? We're going to write his size. And then, okay, we're going to write his size, and then we're going to write them all out. Okay. Now, let me show you some of this. Okay. This is, I guess I could probably load it in. The easiest way on video is going to be to come up here to the game. Let's go ahead. No, wait a minute. Let's go ahead and do save. Okay. So, let's go ahead and bring this up because I want to show you these. So, to do project, come on, catch up with me, hurry up, don't crash. Come on, I've been working real hard on this grid math stuff. Whew, what a pain. Okay, so let's come into war game. That's the pinnacle object here. So if we look up here, here's war game, and we have our export game maps, and we'll have an export war game. Okay, so if I come down here to export war game, now you can see how I'm doing this. We're exporting the war game. All we need is a file name, and then you give me a handle to the object, the game that's in play. And then he's just going to come through here one field at a time and write it out. When you get to the RTF fields, when you get to the clobs, when you get to those guys, then you do it this way. You know, you come in and you say, okay, the text equals this synopsis. We get the address of the text, and then you get the length, then you get the length of the how big it is, and then you write the data of what's in the memory for the length to the file name, to the file handle. Okay, so we create an initial file handle at the top of this whole pyramid of junk, and then we just come through and we write all the longs, we write everybody out, and then we're going to export our game map. Now, one of the things is that if a file is identified as a child class, then the export automatically knows to go ahead and build these functions here that say, okay, we're going to export the child class, and we're going to first write the long to the of how big the file is, and then we're going to iterate each record, and then instead of trying to dump it all in here, well, game maps, the job of game maps is to take care of everything to do with game maps. He's got an export function, and we call him, and we're just going to pass our file number along with the class, the actual map record object that we're listing through on our game. Okay, And this now kind of repeats itself. Let's see, did I get that? You're coming up. Okay. So it now exports. He's picking up the file name. He receives the game map that we're passing it, and he starts over. He's writing himself out. And this one obviously has an image. So instead of having to deal with uh, sprite sheets or any of that crap, it's already in here. It's actually going through and saying, okay, if that's an image, we're making sure we're using the PNG, we're defining it, the stuff out, we're encoding it, we write how long he is to the file, provided he has a length, and then we actually write the binary out, the data out to the file, and then we just keep going. Okay. The next field, yep, it's another picture. Cool. And what are these? Well, these are the sub map owns players. Okay. Each map has its set of players. Each map has its set of game units. Each map has its collection of cities. Um, Oh, this is map layers. I keep looking at that going export players, but I'm trying to figure out why that's a capital L. That's export map layers. Then we have export game players. Ugh, my eyes, what can I say? And then we have export terrain rules. Okay, so these are all the pieces that make up the map, and each one is really responsible for itself. The parent is responsible for iterating the collection because the parent owns the collection, but then he calls the lower level to go do his thing. So in doing this, you now end up with an exact element by element save of your object model. Okay. And this, believe it or not, is almost as fast as that JSON save. This maybe takes a half a second longer. I don't care how big this is. This is unbelievably fast. The first few times I did this, I worked really hard to build a progress bar thinking that this was going to take time. And it ran so fast that my code for trying to do the progress bar slowed the dadgum thing down. And all the progress bar did was go from 0 to 100 in about a second and a half. And it's like, well, what's the worth in having that? And I ripped it all out and it ended up running in less than a second. So this is unbelievably fast. And then exactly the same, remember, we're the programmers. We're telling the system how to work, right? Exactly the same in reverse. You have an import function. Let's come up here and let's go look at the import. We have export. If you have export, you got to have import, right? And I don't think you're not going to do that for me, are you? We'll just come over here and find him. Okay, so, that's going to just find a call to him. Okay, fine. There he is. Okay, so we're going to import the map layers collection. This is just the same thing in reverse. Basically, all you'd have to do is copy the export and then do a change all replace just about from the word export to import, and 90% of your code's fine. Obviously, the clobs and the RTFs and the images and stuff like that will all be bogus. But still, you've just written it all out and then you bring it all back. And this saves you from having to deal with sprite sheets, with everything, because this is the actual game exactly the way it was when it was saved. So when it loads back up, the system just remembers right where he is. Some of the last fields I put into the game are up here, and they are, what is my current turn? What is my current map index? Who's the current player index? What is the current phase time? So as long as that data is saved with the parent, then when you load the game back into the system, those are the things that tell the program where we left off and pick right up and just keep playing. Okay. So this is really a look at import, export, and files, and these things are really are tremendously powerful. Let's see. Let's jump back. I don't know what all else to put in here. I'll probably put some. Didn't I? There it goes. Okay. So, I mean, you've got a whole slew of reads and run and writes, and they even have a truncate. And for those of you from not too familiar with the word truncate, truncate means I open the file, hit truncate, everything in that file's gone. You got to open and a close. It's an empty file. Now, file's got some other capabilities, and these are kind of in Pete's world. These are somewhat throwbacks. Well, the file seek is really a throwback to the DB2 days, database, uh, the old DBase 2, 3, 4, and 5. We always had the file seek because that was the only way when you wrote records, you wrote flat file records out of your database, which was used to be the only way really to do this. A lot of it back old days. And you would do a seek on your ID, and it would scroll through the file looking for a match. Okay, I don't think I'm sure somebody can find a use for seek today. You have end of file if you've reached the end of the file. You have location, and you have the length of the file, so you can identify how long a file is. That's very popular if you're like loading it into memory and it's an image file. You want to know how many bytes are involved in it, that kind of thing. But that really kind of is the gist of this. Now, what I'll do is I'll throw some more of that exporting code. I'll clip some images and the RTF, the editor kind of fields and stuff. So you have the reads and writes for those into this file. And I'll end up putting it out there on my website for y'all to download and take a look at. For those of you using Class Builder, let's go ahead. Class Builder can actually build this for you. When you create a class, I'll just go ahead and add this. So when you come into Class Builder and create a class, you have this build export flag, and build export will automatically add the import and export of this class. Now, if you do not check the child, then each import and export is expecting a file name to load itself, because either a class is a parent class standalone or he's a child. If he's a child, he's going to get past the number of the file that's already open for him to write to or read from. If he's not a child, then he expects a file name to be handed to him for him to save himself and his children. So you got to be pretty religious about the whole child collection flag, but he'll automatically build those steps for you. That really is what I wanted to point out on this video. I believe it's probably getting way too long, but that is files, a good deep read into files, okay? And how they're used. They're used for an awful lot more than just saving the occasional piece of text or image. You can save entire trees, and it's really impressive. So I want to thank you all for your time and watching the video, and we'll come back again real soon with another one.